Okay, so 12.5. Curvilinear motion in rectangular coordinates. So we'll represent positions with vectors. I'll call the position with the vector r, and r is defined as the x coordinate times I, which is the unit vector in the I direction, plus y times j, where j is the unit vector in the y along the y-axis, and then z times k. Okay, I, j, k are unit vectors along x, y, and z axis. And x, y, z are scalars representing positions along x, y, z axis respectively. Sometimes you're asked to find not the vector but the magnitude of the positions. In this case, to find the magnitude, which is denoted by 2 bars, what you have to do is take the x component, square it, take the y component, square it, and sum it up with sum the 3 components when squared. Okay, so this r is called the magnitude. This term indicates magnitude of vector. If you put r here, then it's the magnitude of r, but it can be anything. So similar to position, we can find the velocity, which will denote by v. So v is the rate of change of position. So take the x component, the y component, z component, and differentiate with respect to time. So I can write this as dx dt I plus dy dt j plus dz dt. Okay, it's often written in this course, the way I'll write dx dt is x dot, where the dot implies its differentiation with respect to time, plus y dot j plus z dot k. Okay, similarly, similar to the previous one, you can find the velocity magnitude. It is simply x dot square plus y dot square plus z dot square. And finally, we have the acceleration. Okay, acceleration is the second derivative of position. So when I write x double dot, just means that it's let me write it on a new page. It just means it's d square x dt square and so on. So we complete this. Acceleration d square x dt square I plus d square y dt square j plus d square z dt square k, which in short form is, in shorthand notation, is x double dot I plus y double dot j plus z double dot k. And then if you want to find the magnitude, simply x double dot square plus y double dot square plus z double dot square, and you take the sum. So either you're given positions and you got told to find velocities, acceleration, in which case you differentiate, or vice versa. You're given accelerations and you got to integrate to find velocities and positions. So the problems are basically in that flavor. Given velocity or given acceleration, given position, find other things. Okay, start. Were you guys able to download this from Blackboard? So there's no 12.4. We start from 12.5. Great. A particle originally at rest and located at 3, 2, 5, which means that the x position is 3, the y position is 2, and the z position is 5, is subjected to an acceleration of 6ti plus 12t square k. Determine the particle's position x, y, z at time t equals 1 second. Okay, so as I said, if you're given the acceleration and told to find the position, then you got to go from to find the position from acceleration, you got to integrate. Okay, so what we'll do is we'll do it one step at a time. So acceleration is 6ti plus 12t square. So what we'll do is I'll write the acceleration in the x direction. Okay, only the x component. It's 6t from here. Okay, I'm going to try to find the position x from the acceleration. So I'll write acceleration x is related to the velocity by this formula: dvx dt equals 6t. So dvx equals 6t dt, and then if I want to integrate this, I need the limits. So are we given something about the velocity? Well, we're told that the particle is at rest. So initial velocity is 0. This is at time t equals 0. We want to find its new velocity vx, which is the unknown, at time t equals t. The reason I wrote time t equals t and not 1 is because eventually I want to find velocity as a function of time, use that expression to find x as a function of time, and once I do that, that's when I'll put x t equals 1. So Vx equals 6t squared divided by 2. Upper limit is t, lower limit is 0. This is 3t squared. Vx is dx dt equals 3t squared. So dx equals 3t squared dt. And I can integrate this from the x limit is 0. Well, my bad. At time t equals 0, I've been told that the position is 3 right here. So I need to put 3 here, not 0. Okay, and then I need to find the position at time t equals 1. So x is the integral of dx, upper limit is x, lower limit is 3, equals 3t cubed divided by 3, upper limit is 1, lower limit is 0. So I get x minus 3 equals 1 cube minus 0 cube. So x equals 4. Okay, is that clear? Okay, so we do the same thing with y. What is the acceleration in the y direction? It's 0, right? Because there's no j component, there's only I and then there's k. So acceleration in the y direction is 0. So dvy dt equals 0. Take the limit dvy equals 0 dt. Initial velocity is 0, right? Because the particle starts from rest. Initial time is 0. You want to find the new velocity. So this should be vy at time t equals t. So the left side is simply vy equals what's integral 0 dt? 0, right? Okay, so just think of it this way. If a particle is at y equals 0, it's at rest, and subjected to 0 acceleration in the y direction, its velocity is going to be 0 because there's no acceleration. So it has to be 0. If the velocity is 0, it's obvious that the position is going to be 0, right? So you could use that reasoning, or you could just use the integral. So we can write dy dt equals 0, and again you get dy equals integral 0 dt. The initial position is, well, it's 2 because you're given here 2. The final position is unknown, that's y. Initial time is 0, final time is t. Left hand side we get y minus 2. Right side 0 dt is 0. So we get y equals 2, which is not surprising. If the particle is located at 2 feet and is subjected to 0 acceleration, 0 velocity, it's going nowhere. It's just going to be the same place. Yeah, question?
We have to show that extra order.
No, you don't. Just say that it's, if you say it, then you should be good. You don't have to do this work. Okay, finally, AZ is 12t square. So dvz dt equals 12t square. So integral dvz equals integral 12t square dt. The initial velocity is 0. We want to find the velocity vz as a function of time, so upper limit is vz. The lower limit for time is 0. The upper limit for time is t. So we have vz equals 12t cubed divided by 3 t0. So vz equals 4t cubed. And then this gives me dz dt was 4t cubed. So the lower limit is 0, not 0. I think it's not, it's 5, right? So initially the particle is at 5, which means that the time is 0. New limit is z, and then we want to find the position when time t equals 1. So z minus 5 equals 4t raised to 4 divided by 4, 1, 0. So z minus 5 equals 1 raised to 4 minus 0 raised to 4. So z equals 6. Okay, so you could keep the answer this way, or you could write the position at t equals 1 second is the x coordinate is 4, y coordinate is 2, z coordinate is 6. Any questions? Questions? Okay, let me do this and then we'll do the pre-lecture question. A particle travels along a path defined by the parabola y equals 0.5 x square. If the x component of the velocity is 5t, find the distance from origin at t equals 1 second and the magnitude of acceleration at t equals 1 second. We're given that at time t equals 0, x equals y equals 0. So let's see what's going on here. You're told that the particle travels along the path defined by a parabola. So I'm going to draw that parabola. Initially, it starts from it's the parabola, passes through the origin. This is x, this is y, and then for every y value there are two x values. It means that the parabola is like this. Okay, this is y equals 0.5 x squared. You're also told that initially the particle is at x equals y equals 0, which means it's right here. This is where the particle is. Okay, and it's confined to moving on the parabola. We do not know if it's going to the right along the positive x-axis, positive x, or the first quadrant, or it's going in the second quadrant to the left. Okay, we can get that if we integrate the equation. So we are told that x dot equals vx equals 5t. Okay, and we are trying to find the distance from origin at t equals 1 second. So let's try to see where we get using that equation. X dot equals 5t. Okay, so in order to find the distance from origin at t equals 1 second, I'm going to try to solve for x at time t equals 1 second and y at time t equals 1 second. Once I know the x and y position, the distance from the origin is simply the square root of x squared plus y squared. Okay, so let's try to solve for the x component at time t equals 1 second. dx dt equals 5t, and so dx equals 5t dt. The limits are at time t equals 0, x is 0. I want to find the position x at time t equals 1. So x equals 5t squared divided by 2, 1, 0. So that gives me 2.5. Okay, I got the x position at t equals 1. So this is at t equals 1. What's the y position at t equals 1? Yeah, so since the particle is going to be confined to this parabola, if you know the x coordinate, then you can immediately find the y coordinate because it has to satisfy that equation, y equals 0.5 x squared. So I simply put it in this equation, 0.5 times 2.5 square. I think it comes out to be 3.125. Okay, so now to find distance from origin, it is the x component square plus y component square. It's 4 feet. Okay, so which means that it's going to be somewhere here, 2.5, 3.125, right? At t equals 1 second. Okay, and distance from origin is simply the distance, the Euclidean distance, which is just what I've written down from 0. The second part asks to find the acceleration at time t equals 1 second. Okay, we know the velocity Vx. We do not know Vy. Let's see if we can solve for Vy too. Vx is 5t. So to find the acceleration in the x direction, I've got to do ax equals dvx dt equals 5. Okay. I also need to find ay. How can I find ay? Of derivative of this. Okay, so let's do that. So y equals 0.5x square. Let's take the derivative of y. So dy dt, that is vy, equals 0.5 d dt of x square. Okay, the way you do this derivative is you get 2 dx dt. Okay, so if you take the derivative of x square with respect to x, it's 2x. But when you take the derivative of x square, is that right? That's not right. It's 2x dx dt. This is the right way to do it. The reason is that when you're taking the derivative of y, which is a function of x, this x is actually a function of time. So when you take when you take the derivative of y with respect to t, you need to go, another way of thinking of this is, you can write this as x square dx dt. What rule is this called? Is that chain rule? Okay, so you can use chain rule. Okay, and I'm doing this only because x is a function of time. So this gives me, it'll give me the same thing, 0.5 times 2x times dx dt. This is another way of thinking about the same thing. Here's one way, and that's the other way, but you get the same answer. Okay, so we got y dot equals, this cancels off, so x times x dot, right? Dx dt is x dot. But we are interested in ay. Ay is second derivative of y dot. So d, write this as vy equals x times x dot. Okay, so I need to find a y, which is dvy dt. Okay, I'm going to use the chain rule again now. So the other thing is, this is a formula involving a and b. When you have to differentiation of two terms and each of those terms are function of time, the way you do the differentiation is keep one of them constant, differentiate the second one, and then do it vice versa. So let's keep x constant, okay, and then take derivative of x dot, and then keep x dot constant, take the derivative of x with respect to time. Okay, that's the product rule. Okay, so dx dot dt is basically saying what's the derivative of velocity in the x direction. So this is x times, what's this? It's ax, right? The derivative of velocity is acceleration, plus x dot times dx dt is simply x dot again. So we need to find acceleration y at t equals 1 second. So we need to know what the x position is at t equals 1 second, but we already know that. We actually found it right here. We found that the x position is 2.5. So 2.5 times ax, which is 5, plus x dot. X dot is Vx, which is 5t. So I can write that as 5 times 1 because time is 1, and again 5 times 1. So let this come up to 37.5. Okay, so we asked to find the magnitude of acceleration. So the last step is to find the magnitude, which is equal to ax square plus ay square, which is 5 square plus 37.5 square, 37.83 feet per second square. Okay, is that clear? What's that? Yeah, recording. Okay, I want you to solve this problem. This is from the pre-lecture. A particle is constrained to travel along the path x equals 4t raised to 4, where t is in seconds. Determine the magnitude of the particle's velocity and acceleration when time t equals 0.5 seconds. So in the interest of time, let's skip acceleration. You can do it later. So I want you to find velocity, okay, which is vx square plus vy square. So I just wanted to find the magnitude of the particle's velocity. You're given that the particle follows the parabola, okay, a different parabola compared to what I had done in the earlier question. So find velocity and pull your answers. I'm going to turn the iClicker on. If you have to use the frequency which is posted right here, DC. So just indicate the value. You don't have to give the units. Okay, just put the value in meters. As the poll is open, right? Can you see the poll? I already have some people. So you have to first use this frequency BC. So click on, choose the frequency, and then poll answers.
How many sequences would you like in?
Just put 2 decimals. Or even 1 will do. Yeah. You can do this. Is this the technical code? Should be the code. Yeah. You should be able to poll the answer using articles.
That's how the dashboard. Like a 50, like to get let's see, like wait, yeah, that's what it is, right? I think the best one is yeah. But I don't know what my actual grade was on my lost one. Yeah, mine
Did everybody try iClickers? Yeah, not working.
How many sequences?
You can just put 2 decimals or 1 decimal is fine. 1 or anybody else having issues with iClicker? Okay, I'll stop in 2 minutes. Here is so the list of people who have not polled answer, the people who's and this. So you can see these numbers. These are this indicates that this person has not registered. He's not linked his iClicker account with the Blackboard account. You need to go to iClicker Reef, which is on Blackboard. There's a tab there. Click on that. It'll take you to the iReef website, and then you'll be able to link the two. If it is a check mark on your iClicker, it means that I've received your answers. So if you are having a hard time, please talk with your neighbor and they might be able to help you. Okay, yes, Jan.
No.
Yeah.
then we can pull up the registration, make sure that I'm registered. So I don't online.
I'll arrange it by first name. What's your name?
My name is Dylan.
No.
It's cool, right? That's how you look at it.
You might be one of these 4 people.
It'll save your answers.
Yeah, you'll save your answers. Don't have to worry. So if it shows as a number there, you don't have to worry because that means that Iris has taken your answers, just that it is not going to be transferred to Blackboard. So you can link the two later on, not a problem. Okay, I'm going to stop in like 30 seconds. If you did not get iClicker, or if it's not taking an answer, you can just write it on a piece of paper and give it to me. I can take it and manually give you a score. So those people have to poll an answer. Okay, I'll stop in 30 seconds. So another thing is that if you get the right answer, you get a full point. If you attempt it, you get 75% of credit. So I recommend that you should at least attempt it. If you do not attempt, you're going to get a 0. If you attempt, you get 75% points. And 1 point for doing it all right. Okay, I'm going to stop. 3 people have not responded. This is alphabetically. Okay, anybody wants to give in a piece of paper? I'm going to stop. Okay, let me solve this and we'll move on. So x equals 4 t raised to 4. So since you are interested in finding the velocity, I'll try to find vx and vy. X dot is vx. So differentiate 4 t raised to 4 gives me 4 times 4t cube, which is 16t cube. If I want to find x dot or vx at t equals 0.5, I just put 0.5 in the expression. That's 2. And then I need to find, so I know that y square equals 4x. Okay, or I can write y equals 4 square root 4x, which is 2 square root x. If I want to find y dot, which is vy, it's going to be 2d dt of square root of x, which is 2 times d dx of square root of x times dx dt. Okay, that's chain rule. So derivative of square root of x is 1 divided by 2 square root of x. Is that right? I think it's a negative. It's positive half, right? Okay, and x dot. So this 2 cancels with this. So x dot divided by square root of x. X dot is right here. It's 16t cube. And x, square root of x, I need to take square root of 4t raised to 4. So 16t cubed divided by 2t square, that's 8t. So y dot is Vy is 8 times 0.5, which is 4. And finally, to find v, which is vx square plus vy square, it's going to be 4, 2 square plus 4 square. 4.47. Okay. That's right. That's close. That's sounded. That's fine. There you go. So a particle goes from A to B, so this way, and from B to C and C to A. Okay, and you're given the time in which it goes. From A to B is 5, B to C is 8 seconds, and C to A in 10 seconds. So you find the average speed and average velocity. So this is a problem which illustrates the difference between average speed and average velocity. Okay, let's write the definition of average speed. It's basically the total distance traveled divided by the total time. So let's find the total distance traveled. It's basically the distance from A to go to B, and then the distance to go from B to C, and then C to A. So from A to B, it has to go through a quarter of a circle, right? The circumference of a circle is 2 pi r. A quarter is going to be pi by 2 times r. Pi times 20, that's a half circle, so that's going to be half of this. Plus B to C is, how do you find B to C? You have to use the Pythagoras theorem, right? This is 20, this is 30, so 20 square plus 30 square, the square root of that. And then C to A is, this is 20, and the other distance is 30, so 30 plus 20 is 50. So what does that come to? 10 plus I got 117.47. So the speed, average speed is 117.47 divided by the total time, which is 5 plus 8 plus 10. .64 meters per second. Next is average velocity, which is defined the displacement divided by the total time. So what's the displacement? It's 0, right? It starts from A, comes back to A, so the displacement is 0. Because displacement is 0. Okay, so that's the answer.